Okay, so this is Nuclear Chemistry, Half-Life Part 2. And in Part 1, we defined half-life as the amount of time needed for half the sample of an isotope to undergo nuclear decay and become a new isotope. So take a look at this graph here. This graph represents half-life. And for this particular sample, half the material undergoes nuclear decay every 10 days. So if we start with 50 grams, after 10 days we have 25 grams. After 20 days we have 12.5 grams. After 30 days we have 6.25 grams, and it continues on. So this is how a typical half-life curve looks. So let's ask ourselves a simple question. If we started with 200.0 grams, how long would it take until we had only 12.5 grams remaining? Well, there are two ways to solve it. The first way is the simplest way, and it's simply counted out. So let's start it out with 200.0 grams. 200 divided by 2 is equal to 100. That's one half-life. 100 divided by 2 equals 50. That would now be two half-lives. 50 divided by 2 is 25. That's three half-lives. And 25 divided by 2 is 12 and a half. That is four half-lives. So we have four half-lives. It takes four half-lives to go from 200 to 12 and a half. So what that means is that four half-lives times 10 days per half-life will be 40 total days. Now that's the first way to solve this problem. There's an alternative. We could use an equation. And the equation that we could use is A naught times 0.5 raised to the n equals A, where A naught is the starting amount, A is the amount remaining, and n equals the number of half-lives. So if we start with 200 grams, how long will it take till we only have 12.5 grams remaining? Same problem. We're going to plug these values into our equation. So we take 200.0 times 0.5 raised to the n power, where n is the number of half-lives, and that's what we're solving for, equals 12.5. So first step, now that we've set up the equations, we're going to divide both sides by 200. And when we divide both sides by 200, we get 0.5 raised to the n power equals 0.0625. 12.5 divided by 200 is 0.0625. So now we have an expression that we can convert to a logarithmic function, or a log function. And you should, if you don't understand how to do this, you should look at the log video that I've made, so that you see exactly what we're doing here. Okay, but the log of 0.5 of 0.0625 equals n is our logarithmic function. Now normally logs are written as either natural logs or base 10 logs. Here we have a 0.5 base log. So our base is 0.5 instead of base 10. So we need to do a little math to actually figure this out. The log of 0.5 of 0.0625 is equal to the log base 10 of 0.0625 divided by the log base 10 of 0.5. This is the only way we can solve this, because you can't plug this expression that we have into a calculator. Your calculator doesn't have that functionality. So what we're going to do is we're going to take the log base 10 of 0.0625, and that gives us 0.1204, and the log base 10 of 0.5, that gives us 0.301. So we now divide those two numbers, and we get the log of 0.5 of 0.0625 equals 4, which means n equals 4, which gives us the number of half-lives. So since 4 half-lives, 4 times 10 days is 40 days. Same answer. Now you might be thinking, why would I go through that process when I could just count it out? Well, not every problem is going to be simple enough that you could just count out. You're not going to always fall right on the exact half-life timeline. So, for example, if one has 200.0 grams of actinium-225, which has a half-life of 10.0 days, how long will it take to only 10.0 grams remain with 200 so what we're going to do is we're going to start with 200.0 grams, just like we did last time. And 200 divided by 2 is equal to 100. That's 1 half-life. 100 divided by 2 equals 50. That's 2 half-lives. 50 divided by 2 is 25. That is 3 half-lives. 25 divided by 2, that equals 12.5. That's 4 half-lives. And 12.5 divided by 2, that equals 6.25. That's 5 half-lives. So we're somewhere between 4 and 5 half-lives, because we want to figure out how long it takes to get to 10.0 grams. We're not at 4 half-lives. We're past 4 half-lives, but we're not quite to 5 half-lives. So we need to use the equation to actually solve this problem. So the equation is, again, a naught times 0.5 to the n power equals a, where a naught is the starting amount, a equals the amount remaining, and n equals the number of half-lives. So we're going to plug in our values. 200.0 times 0.5 to the nth power equals 10.0. Divide both sides by 200, you get 0.5 times, or to the nth power equals 0.05. We're going to convert this to our logarithmic expression. You get log of 0.5 you get log of 0.05 using the 0.5 base equals n. So now we have to go through the process of solving the logarithm. Well, log of 0.05 to the 0.5 base is equal to the log of 0.05 over the log of 0.5, which is equal to 1.301 over 0.301, and those are both negative, which is equal to 4.32, which equals n. So n equals 4.32. Therefore, it's 4.32 half-lives. That's how long it takes to go from 200 grams to 10 grams. So that's how many half-lives will have passed. Well, 4.32 half-lives times 10 days per half-life is 43.2 days. 43.2 days is how long it will take to go from 200 grams to 10 grams. Okay. So these are a couple of half-life problems, and you should practice these, and hopefully you'll understand it.